Hey everyone, and welcome to AWS Nordics Office Hours Ask Me Anything edition. My name is Gunnar Grosch, and I am a senior developer advocate here at AWS. And I am extremely happy to have my friend Adrian Hornsby here with me today. Welcome, Adrian.
Hi, Gunnar. Thanks for having me on your show. It's great to be here and awesome to see you as well.
Yeah, great to have you here. And today, I'm very excited to have you here to talk about AWS Fault Injection Simulator. It was pre-announced during re:Invent by Werner in his keynote. So today, we're going to spend this hour to talk about FIS, as it's also called, to look at how we can use it, why we want to use it, the benefits from it, and so on. But given that this is Ask Me Anything question, just keep your questions coming in the chat, and we'll try to answer them as we go along. So before we kick things off with you, Adrian, I just want to show people the upcoming schedule. As you know, we have these every Monday at 1 p.m. CET, and every week we have a topic besides the questions you have for us. So the next week, we're going to talk about streaming and real-time analytics with serverless. We have Sini Teamforge on. Then we have serverless upcoming, containers, and several episodes on AI and machine learning. So keep coming back every week for more great stuff from AWS experts from the Nordics. So now,
these are real experts, actually, and they're awesome people.
They are. Several of them are solution architects working with these topics and these services on a day-to-day basis with customers in the Nordics. So, Adrian, before we kick things off talking about Fault Injection Simulator, tell people a bit about yourself.
Well, actually, I already had the question for you because I heard you say FIS. Is it FIS or is it FIS? And what is the debate there?
Is there a debate?
I don't know. I'm asking you.
No.
I'm saying FIS because it sounds fizz. But
well, if you're from the Nordics, I think you say FIS instead. Okay. You're not really from the Nordics. You live in the Nordics. You've been there for quite some time. But, I think we use each letter by themselves. I don't know, but
it's probably one of those surveys that's going to be debated for years to come, I guess.
It might be. So put a comment in the chat and tell us how you want to say it, FIS or FIS.
So right. to answer your question, right? So I'm actually part of your team, mate. Yeah. I'm part of the technical evangelist team, and I've joined Amazon about 5 years ago. Actually, I celebrated my 5 years anniversary in early January, and so I joined as a solutions architect, then moved to evangelism attached to the Nordic, and now I have a specialist role, which is a more global role, and I work on the topic of resiliency, kiosk engineering, operational excellence, and such a thing. So I've especially been doing quite a bit of work, actually with you as well, quite a much around the topic of kiosk engineering. You've digged onto the serverless parts, and I've digged onto more the infrastructure and EC2 parts. So kind of a year and a half ago, got some, started to work on some ideas, and then with a bunch of people internally, and like a few months ago, one of this big thing happened. AWS FIS was launched, and so now I'm here to talk about it.
Yeah, that's awesome. And as you said, we've both worked in the field of chaos engineering, and tried to get people to learn more about chaos engineering as a practice, and that's one of the reasons why we're here today as well. Not only to talk about the service, but also talk about the practices and why we want to do it.
And the community at as well. I think chaos engineering is a very interesting community.
It is, for sure. So let's let's start there then. First off, with the launch or the pre-announcement from Werner. So that was during his keynote, an awesome keynote, by the way. Was it a sugar factory in the Netherlands?
It was really beautiful. I liked it.
It was. So he talked about, as he usually does, how we build things and talking about reliability, resilience, and so on. That got him into AWS Fault Injection Simulator. So it is pre-announced, so it is not generally available yet, but during 2021.
Yep, that's the plan.
Yeah, that's the plan. So let's then try to set the stage a bit. Let's talk about the whys, perhaps, the reasons behind it. So we often talk about distributed systems. That's often what we talk about when we talk about using chaos engineering. So can we first off just talk a bit about what is a distributed system?
Yeah, it's a good question. And I think it's often a topic which is misunderstood. I think when we talk about distributed system, often people think about hundreds or thousands of microservices. But it's not that, actually. If you take a simple client-server communication, it's already a distributed system. And it's actually quite complex, because if you want to send a message to a server, your client needs to put a message onto a network. The network needs to deliver that message to the server. The server needs to, validate that message, maybe deserialize it, and then, answer that message, put it back onto the network, deliver. And so there's quite a lot of different operations that are happening here. And all of these different steps are potential areas where things can go wrong, right? And since we're talking about Werner Vogels, he often says that everything eventually will fail, right? And they do. Like statistically, it's impossible for everything to always work perfectly, right? So there's always some intermittent errors. There might be, like a solar flare that disturbs the network, and then your packet is not delivered. You might be a squirrel that is attacking a cable somewhere, or a shark that eats an underwater cable. All these, you're laughing, but all these are kind of actually outages that have happened in the past, right? And it might be digging a cable out by mistake during renovation. There's tons of things that can go wrong, right? And so distributed systems really is not necessarily this very big, massive Twitter, Facebook, Google, Amazon system. It's really, we can think about distributed system more in simple form. And what we mean when we say they are complicated is, well, there's a lot of states there to manage. So, each of those different states is a potential for failure. So, yeah, they're not easy and they are complex.
And the systems we build using AWS in the cloud today, they become distributed more or less by default, some of them, because the ways the services that we use are built and put together.
Yeah, exactly. And the more you go, I would say, the more you go into cloud infrastructure or cloud systems, we tend to use, service from Twilio, for example, or authorization systems from OAuth, or all these kind of systems that are separated, not necessarily managed by you, and each of them can have failure, right? At some point, they might return an error, so you need to handle potentially a retry. You need to potentially handle a disruption of the service at all. Like if the dependency you're calling doesn't work, what do you do? Right? And so, yeah, there's all these kind of interesting scenarios that are happening, and it's pretty crazy the number of things that can happen.
Yeah, and you mentioned it, that distributed systems are complex. That's also something that we hear quite often. That and a question that I think it was Casey Rosenthal, one of the creators of chaos engineering at Netflix back in the days. I saw him ask this question once at a conference: why not just make systems simpler? Wouldn't that solve the problem?
Yeah, I mean, it's a good question. I think we design applications that are globally available now. Like, so if you think about 10, 15 years ago, or maybe 20 years ago, you designed an application that was maybe for your local country, that was maybe for the folks around. Now, you can distribute an application over a marketplace, and all of a sudden you got millions of people that might, start using the application, and all these users are dispersed, across the globe. So if you only have one system somewhere, the latency from that particular user that is maybe on the other side of the planet might be terrible. So it's not a good user experience. So you start to build several units of that system. It starts to be distributed, and all of that, naturally adds complexity. And plus, because we want to innovate faster, we tend to use more and more managed services, like auth from somewhere else, SMS distribution from some other services. So we stitch things together, and by doing that, naturally we add complexity. So you can, it can still be simple, but the under the hood is, your system might be simple. You can build application with 20 lines of code. That's simple. But the problem is the underlying infrastructure that is managed, or all these abstractions are still very complex, because you have a distributed system there under the hood that manage the data, distribute the data, make sure that it can scale, that it's reliable, all this kind of stuff. So it might be simple from an end user point of view, but at the end of the day, there's still someone that has to build the complexity to make it simple for you.
Yeah, and the ways we've traditionally worked with trying to make our application work as intended is testing in different ways. We work with unit tests to test a smaller unit of the system, and then we have integration tests to test pieces together, the different parts of our system. But that really isn't enough when the system becomes this complex distributed system.
Yeah, and I think there's something fundamentally missing when you just use normal tests, because when you do a test, you actually are only testing for something that you expect, right? A behavior that you think might happen, and then you test against this condition. For example, your function, you give it a variable, and your function multiplies that variables by 10, for example, right? It's pretty easy to make a unit test, right? You give an input, and then you verify the output. Now, that being said, in a distributed system, it's very difficult to do that because there are a lot of variables, a lot of things that you don't know. A simple question is, what happened, for example, if your instance cannot write into the disk? Can you exactly tell me in what happened? What are all going to be all the fault conditions from first the instance, then the dependencies, the client, the database, all these kind of things that might be related to it. So all that we call the unknown, right? And all these are things that we can't test for because we don't know. And therefore, that's why these kind of new disciplines, to test the resiliency of complex applications were built, right? And it's not necessarily new. Like some fields, especially in the electronics, they were doing this, quite long time ago, removing a component and see if a second component was taking over, especially for the electric grid and things like this. But in software engineering, it's quite recent, right? And as you said, Netflix has made the discipline formal and very popular with the Chaos Monkeys.
Yeah, so that leads us perhaps to the underlying topic of today, which is chaos engineering. And chaos engineering, it was under that name at least created by Netflix. It's been popularized by them as well. Yeah. But Amazon has a history of doing a similar type of practice and has been doing it for quite some time as well.
Yeah, exactly. And if you look a little bit at the history of Amazon, when Amazon was just a retail site and started to grow, they hired in the early 2000s. They hired a guy called Jesse Robbins, and Jesse Robbins, and he's on Twitter and has written books around the topic. And I strongly suggest everyone to go and check out his books. And so what was special with Jesse Robbins is his background. He was a firefighter, and as a firefighter, he explains that they used to train, almost 80% of the time, so that the crew can build an intuition to fight fire. And he says that when firefighters are sent into a real mission, if they don't have this intuition to fight the fire, if they have to think and try to analyze the situation, it's too late. Generally, they don't have the time for that. So they need to have this intuition so that they can just react based on experience, intuitively. And he wanted to bring that mindset to the operation teams at Amazon. Right? So in the mid 2000, early, so I think 2006, something like that, he created something called the game day, which was an exercise, a large-scale exercise to test the resilience of the retail site at Amazon. So you would go around data centers, and unplug things, and then see how the team would react, see if the retail site would keep up, serving its customers, and things like this. And different scales, right? They might unplug just one server, but he also did a big exercise where he shut down the whole power grid of one data center and see how things were reacted. So, all these kind of things were done, and in fact they're still done today to different levels of it. Right? We can't anymore shut full data centers so easily like that, but there are some large scale exercises that are done regularly. Both on Amazon side and AWS side.
And Jesse Robinson, that all of that earned him a quite great title, Master of Disaster.
The Master of Disaster, yeah.
That's pretty cool. All right, so
and he has an awesome talk, right? He made an awesome talk at QCon a few years ago, back in the days.
Yeah, it's on YouTube, I believe.
Yeah.
So if you just joined us, this is the Ask Me Anything in Nordics office hours. I am Gunnar Grosch, and I'm joined by Adrian Hornsby today. We're talking about AWS Fault Injection Simulator, and we're getting to the actual service. We're just going through the background, talking about distributed systems, talking about fault, failure, and chaos engineering, but we're getting there. So if you have any questions, keep them coming in the chat, of course. All right, so with that then, what kind of things can chaos engineering help us with?
Yeah, so this is a great question, and I think the more we practice chaos engineering, the more we realize that there are many things that chaos engineering can help with, and especially for me, the obvious ones, right, is the resilience. I think that's the original form of the original purpose of chaos engineering is increase the resilience of an application, especially make sure that the application behaves well during an outage. Right? That's one thing. But for me, the more and more I practice chaos engineering, the more I see a massive value in terms of, especially on the monitoring side, monitoring and observability. And I'm talking here about exposing blind spots. Right? Yeah. I think we've all experienced outages where alarms were forgotten or not well set up, and or we didn't catch the alarm on time, or it was lost in the noise of all the other alarms. I think we can all agree that this is triaging alarms and tickets is sometimes pretty hard. And the more I help customers do chaos engineering, and the more I see a lot of benefits there, help people find their monitoring blind spot. That's one thing. The second is on the whole cultural side. and I think that's also probably one of my favorite one. And it's also one that Nora Jones talks about a lot. Nora Jones is one of the original writer of the Netflix book on chaos engineering, and she puts a lot of emphasis on the before and after chaos engineering experiment. And all this before and after is the work that you have to put, to prepare for chaos engineering experiment is really, in my opinion, is really changing the way a culture or a company might operate. And we're talking here about preparing the hypothesis, right? Going around the company and asking what if questions, and all that practice, and I can deep dive into it later maybe, because that can be a full episode. But all that practice of handling the before the experiment and then doing the after experiment. And here we're talking about the postmortem. What happened? What did we learn during the experiment? How can we improve? All these kind of things. For me, this is almost way more valuable than doing the fault injection itself.
Yeah, and I agree on that, because when you start creating your experiments or start off creating the hypothesis for the experiment, you gather all of these people who know different things about the system. Yeah. They perhaps work on different services, they work on different parts of the system. Gather them and talk about the system. You often learn a lot about how the system works. You find the dependencies that you perhaps didn't even know about before. Yeah. How different service teams depend on something that perhaps isn't documented every time. So,
yeah, and there's few things here for me that I love, is especially uncovering people's biases. We all have biases into how we think our application might work. And also the second one is understanding everyone's understanding of a system is always very different. If you take a complex system and you ask them how is that working, everyone usually has a different opinion, and trying to understand why we have a different opinion and what are the missing areas, and just that discussion, the preparation towards the chaos experiment is for me has been really where the growth really has a full potential for a company.
And all of this, I'm already sold on the idea, but for everyone listening to this, it just sounds great. So why isn't every company already doing chaos engineering today?
It's a good question. I would say a couple of things, and this is more from what I've seen, right, with customers. I think the first the word chaos is a hard one to sell to your management. Let's be honest, like. Saying to your management and say, oh, we want to inject failures in production to see how our system reacts, can be a hard thing to sell, right? And this is why, for me, in my opinion, and there's a huge debate here on Twitter around this, saying that chaos engineering needs to be done in production. I'm more on the side of, that there's a learning curve here. This is where you need to earn trust from your company, as well. When you create a chaos experiment, if you go straight into production and you fail, you had one chance, you'll never get it again, right? So you really need to learn the practice, earn trust from all the teams, see, what can be done already in test environment, in staging. And there are tons of things there that will be learned and improved before you go close to production systems. When you launch a chaos experiment in production system and it impact customers and you don't know how to react, it means you haven't prepared well enough, right? So I think that's probably one of the reasons. The second is it takes time, right? It takes time simply because when you want to create an experiment, you need to get people around the table. You need to do a lot of research, and usually it's time that is taken away from developing new features. And there's a hard, I'd say, fight between, very often at least, between sales and operation teams that want to improve a system versus we need to create new features and we need to sell to make the company profitable. So it's like what can we do and what do we not do. But luckily, I think more and more companies are really realizing the value of having chaos engineering and see it as an extension of the testing part and the monitoring and the operation and the big envelope of operation excellence as well. So it's changing.
Perhaps that is a great segment to the question we just got here as well from Jay Kataya. So, hey, Adrian, Gunnar, interested in hearing your opinion on combining load testing with chaos engineering.
Yeah, that's a great question. And actually, we've published an article with Prime Video because I worked with Prime Video on implementing and chaos engineering for their application. And they use load testing as a precondition to run chaos experiment. And this is, in my opinion, one of the best way. I think the most valuable places to run chaos experiment is when you have two conditions. Because if you look at the history of outages, very rarely outages happen because of one problem. Right? They happen, usually it's a combination of small problems that together create a big issue. So having load testing is great because it's going to put the system into stress already by itself, right? You load test, the system is stressing, and then you inject a failure. It's the perfect time there to really see how your system will react to real world failure, because that's when it's going to happen, right? It's the failures are not going to happen when the system is at rest and nothing happens in it. Usually failures tend to happen when it's a full blown, the service is running at full speed, and so yeah, having load testing as a precondition to run your chaos experiment, 100% great.
Yeah, no, I agree. It is definitely something that, and also when you talked about perhaps not doing things in production, being able to do your experiments in a more production-like environment, even though it's not production. And I've seen example of companies using replaying of traffic as well. So
yeah, and that's basically
the actual production traffic.
And that's also what Prime Video does. I mean, we explain it in the article. Is we are using tests. So we create the hundreds or thousands of test user accounts, and then we create scenarios where each of those accounts are simulating real user, and then we inject failure on those accounts so that it doesn't necessarily touch real customer or production customer traffic. That's a great way.
Then perhaps on to AWS Fault Injection Simulator. And the first question around that is it a simulator, or does Fault Injection Simulator actually inject faults into your system?
Yeah, so it does actually inject faults, right? So if you inject fault with Fizz or FIS, I'll say Fizz because it's easier, AWS Fizz, the fault is actually going to be injected. It's not the simulation of metrics or anything like that. We actually going to stop the instance if that fault that you want to do is a stop instance. We actually going to reboot the database. We actually going to terminate a node in a ECS cluster or EKS cluster. So yeah, the faults are actually really happening.
Yeah, that's great. And so then perhaps a word of caution about where to inject these faults as well.
Yeah, and we've made it on. If you use the console, we've made quite a few steps before you can actually start your experiment for that very condition. Like you need to be sure, right, that you're doing it the right place.
And we'll move to the console and have a look shortly, I believe. So, but first off, talking about that then, when you do chaos experiments, we've talked about perhaps Fault Injection Simulator is a way to make it easier to get started using chaos engineering on AWS. That's one of the pure benefits of using Fault Injection Simulator, right?
Yeah. I mean, as chaos engineering is quite a new discipline. Working with customer, it's become clear that it was not an easy discipline to do, right? And currently, if you look at the space of chaos engineering, if you want to do it in a full production system, well, in your environment, right? Currently you need to have different tools, right? You need to have scripts, some libraries here and there. You might need to install an agent. Currently it's really like stitching things together, which is okay and it's possible. It's just that the way to get started is not necessarily easy and accessible to everyone, right? It's quite steep, the learning curve to be able to do that. So yeah, why we did the AWS Fizz was really to make it very easy for our customers to get started with chaos engineering, and having one place where they could do pretty much all the chaos experiments and all the type of fault injections that is required to currently for chaos engineering, right? So it's really is a platform that is going to manage and support different types of what we call actions, which are different type of fault injection, whether they are on the network, on the infrastructure, or your applications.
Great. And another quite important part about having a managed service for chaos engineering is what we're calling safeguards. So yeah, what is a safeguard in Fizz? Right.
So one of the most important thing in chaos engineering is really this big red button. You might inject faults, and then you might realize that something is not going the way you had planned, right? So you might throttle an API, and you start to see that, actually it starts to impact other types of service, or my big steady state, which for example might be your orders per seconds or whatever it is starting to get an impact out of it. Because remember, the point of doing a chaos experiment is to inject fault and be resilient, right? So if you have a steady state that you monitor as an output, and that steady state changes dramatically during an experiment, there is a problem. So you need to stop, right? So a safeguard might be monitoring that particular steady state through a CloudWatch alarm, or in the future there's going to be an event bridge integration, and then that as soon as there's a change in that alarm condition, then we stop the experiment and we roll back to the condition that was initially before the experiment. Now, words of caution, sometimes it's impossible to roll back, right? When you terminate an instance, your instance is terminated, and you can't resurrect an instance that is terminated, right? So that's why it's very important to practice and to know exactly what the experiment is going to be doing.
So it depends so it depends a bit about what type of experiment you're doing, what that rollback action is then.
Correct. And most of our actions, we have a default rollback that you can enable or disable. And all that is going to be documented. So whether it's in the documentation, or we're also going to give a bunch of templates how to run that, and I'll show you a bunch of those templates today as well.
And while answering that, you also answered one of the questions we got in the chat in regards to additional integrations for Fizz, that we're gonna support event bridge integration, so you can integrate using event bridge.
Correct. Yeah. So currently for GA we have a CloudWatch integration, so CloudWatch alarms, and then event bridge is going to be coming.
That's great.
Shortly after.
Yeah. So is it time perhaps to move into a bit of a demo? I think so.
If you want, we can do that.
We've kept people waiting for 34 minutes now, so I think it's time. So there we go.
All right. So this is I would say this is the console for Fizz, right? So here you're gonna have access to the Fault Injection Simulator. You can have your create your experiment directly here. You have your experiment templates, and you see I have quite a few of those. You can see a bunch of different actions and all the different experiments that you run, right? So I've run quite a bit of experiment, as you can see. But let's go back to the beginning, and let's create an experiment. So here we can do a demo experiment for the Nordic. We create an IAM role. So I have my role here, and that role will be documented, and of course will be created for you as well. You can add a bunch of different actions. So here you have the action type. So for example, if you want to stop an instance, terminate an instance, drain container instance, do an EKS terminate node group instance, there is a wait function. So if your experiment needs to wait, you have DB failovers, reboots, and an integration with SSM, which I'll show. We can start quite simple here, just stop instance. We'll call that, here we have a target that is automatically created, which is called instance target 1, and it's here, and we'll go and modify that. Right. Here we can define if an action starts after something. So when you have a different set of actions, you can define if an action needs to start after one another or in parallel. Right? So now I have only one action, so it's fine. And then here is the action, the parameters of the action, so my stop instance. And here I can have a duration, which is going to be the time it takes before I'm going to restart the instant at the end, right? So as I said, we have a rollback. So if I put here to true, here I can have a duration, and then I'm saving that. So I say after 1 minute, I'll restart. Okay, and here I can see my targets, and I can either, of course, target by resource IDs. So if I want to restart any instance, here I have a bunch of instances. If I want to resource by tags and filter, then I have selection mode, and I'll explain this while we do the templates, because it's nicer to see the template. But for example, I select my resource here, one of them. So I have my instance here. Oops, did it? Yeah, there. Yeah. And I can create a stop condition, and this is an alarm, a CloudWatch alarm. I won't do it now. I'll show you at the end of full experiment how to do the alarm, but this is basically a CloudWatch alarm, okay? And then you can create a tag. Let's put the name here, and we'll do a stop demo. And then we can create the experiment.
And that's a good prompt to see, that you have these prompts in FIS, so that every action you're taking, you actually need to confirm that. Because you can basically stop production, worst case scenario.
You will do, if you're not careful, you will do some damage. And it's fair to say there's tight integration with IAM as well, right? So and there's some recommended best practices here that you should be very careful to what kind of power you give to the users using FIS. Do you give power to do experiments in prod or only in test, in beta, and everything else but prod? And at the beginning, your policies and your needs to be tight and fail proof. So here we have that. We can verify, of course, that my stop instance is working. So I have a duration of 1 minute. Start at the end, yes. Okay. Then I have my targets, and you can verify that the target is my instance ID here that I selected, right? So 528. So this is this instance that's going to be here. And then we can just, you can also see the tag name stop demo, and then we can either update the experiment, we can change there. And so this is my template now, or I can just simply execute that. And when you start again, it needs to be from, you're about to start your experiment, which might perform destructive action on your AWS resources. So make sure that you review the best practices and planning guidelines. So once we do this, we can see the experiment is running. It's started. Again, you have access to the targets, and you can see, and shortly after, you'll see that your instance is going to be stopped. So there we go. My instance is actually stopping already. And of course, if you want, you can stop the experiment, and that will also restart the instance automatically without having to wait until the end of the duration of the experiment, which currently was 1 minute. Right? So you see now the instance is stopped, and if I stop the experiment right away, it's gonna be restarting the instance instantly. So that's one of the safeguards that we have for a simple experiment like a stop instance, for example. And this is basically what the Chaos Monkey, the original Chaos Monkey was, right? It's like randomly stopping an instance inside an AZ. Right? So talking about exactly that Chaos experiment, then we can move into those filters, right? So this is the exact the kind of how you can also create an experiment with AWS fees, right? So you can do by the console, or you can do create your templates. And basically the template is the definition of your experiment. And this is a very similar experiment that we just did, right? Simply stop an instance and then restart it. Now there's a bit difference here, is that it's programmatically done, right? So you see I have my tags with the name, I have my description, and then the action, which is a stop instance, the action ID, which is the ID of, I hope you can see, the ID of that action, which is stop instances. Then you have those parameters, right? How long will it start before, how long will the instance stay stopped until it is restarted? And that duration is also the time that we continue monitoring the experiment for these stop conditions, right? So if during those 2 minutes you cancel or there's an alarm, then we'll restart the instance automatically. And this is then the target. My instance, and my target is here, right? So now you see the interesting thing is that is a bit different here is my resources are all my EC2 instances, and I select 3 of them from all my EC2 instances in this particular region. So this is a very wide chaos experiment.
Yeah.
Right. So you can implement a lot tighter ones. For example, here, this is one that is way tighter. So I can have filters from our targets that, based on resource tags. So only the instances that will have the tag chaos ready will be targeted, right? Plus, there's going to be all my instances that are only in this particular availability zone, US East 1B, which have a state running and that are in this VPC. Right, and here I select all of those. Right, so we can try to execute that experiment and see how it goes. And then again, that's gonna last 2 minutes, and then after that, all the instance will be restarted. Now there's a bit different, a slight difference here is actually I have a stop condition now here that is defined, and my stop condition is a CloudWatch alarm, which is called network in abnormal. And I can show you quickly what that is. So this is my CloudWatch alarm, and basically it monitors the network traffic inside an aggregate of all my network traffic from all my EC2 instances, right? So if there's no more network traffic at all, it restarts the experiment. It means that something terribly wrong has happened. Okay. So that's basically how we define a template. Then so let's get the name, fizz stop filters. So then we can do something like that. We create an experiment, right? So was it fizz stop? Was it this one? Fizz stop random
filters.
Filters, yeah. Let's do stop filters. So now the CLI did the template validation and also returned to me an experiment template with an ID here. So my experiment now has an ID, and I can simply start. So let's go back up. Fizz, and I give the ID here. And here now it's pending, so we can go into Fizz, and you'll see that my experiment is now running here. We have an experiment that is running, with the stop instance, the targets, and the definition of all the targets here. Okay. And
so you can move interchangeably between the CLI and the console.
Well, yeah, you can verify. I mean, at the end, as chaos engineering, you wanna gain confidence into the tools, right?
Yeah.
And you can see here, I've stopped now a random set of instances, right? So
US East 1B. Yeah, that's right. So the filters work.
Right.
Cool.
So yeah, and there was all the instances in US East 1B. Okay, this was my filter, and only from that VPC, right? And they all are from that VPC. Right? So that's the kind of filter. So now I can go here and I can say stop my experiments, and then you'll see all the instances are going to be now pending. Right? So the experiment now is rolling back to get back to the state that we had previously defined.
Oh, that's cool. We have a question which I think fits well right now. From your experience, who would you expect to run the attacks and how? For instance, automated in CI, run on demand by SRE teams, application owners through the AWS console?
It's a good question. I think there's a learning curve here, right? So and there's a difference in the type of which companies are doing what, right? If you're in the smaller company, you can't really expect to have a dedicated team to do these kind of things, right? So I would say for me, chaos engineering is more a discipline. It's not necessarily a job title, and I think every developer should learn and understand what it does. And when I worked before AWS, I worked in the company, and we implemented something called failure-oriented design, which everything we built was supposed to be robust against potential failure, and we use chaos engineering to test that. And every developer was aware and could do that. Now, in bigger organization, very often there are dedicated team for that, simply because, well, there's usually a lot more things to take care of. Like you have organization goals, there's roadmaps, there's a lot of stakeholders that you need to manage. So very often we have a dedicated team, and these teams might create the tools and make it very easy for other teams to run experiment. But I wouldn't expect a special special case engineering team to go and necessarily test the code of someone else. I would say they can facilitate, build the tools, and raise awareness, evangelize the discipline in the company, and make it super easy to do it. It really depends on the side of the on the organization. For me.
Yeah, I agree on that, and I think we talked a bit earlier on about what some of the benefits and outcomes you can have with chaos engineering is, and I think it depends a bit on that as well. So
Yeah.
a development team, for instance, they can use it as a way to look for certain things in what they are developing. Then we have operational side of it. They are perhaps using chaos engineering as a way to make sure that monitoring, observability alerts are in place. So
Exactly.
depending on the team, well, my hope and my take on chaos engineering for the future is that it will be adopted by more and more teams. So
Yeah, exactly. And to answer Nico's question, I would say you always start with what we call a game day. Is you discuss an experiment, you tune it, you work with the whole organization to really understand what kind of experiment you want to do. You run that experiment, you learn, you might run it a few times, in a row with improvement in twin, and then eventually you want to turn that experiment into something which Casey and his new company has called continuous verification, right? Which is democratizing basically your case experiment and make them run continuously as part of your CI/CD pipeline, things like this. But to get there, there's a lot of work, in my opinion, right? Because you need to be sure that your system is resilient and that your experiment doesn't take down the system every time it runs. So basically, it's just another way to verify that the development of new feature is not regressing the resilience of the application and the state of the monitoring, the observability, and also the capability for an operational team to react fast to an event.
So if you just join us, this is the AWS Nordics office hours with me, Gunnar Grosch, and I am joined by Adrian Hornsby. Today we're talking about AWS Fault Injection Simulator, and we have about 8 minutes to go, Adrian. So
yes, and I did talk about on Twitter that I'll show you a bit some new things, right? And in the console, there was not this particular actions that I wanted to show you, but we are now able to do what we call control plane fault injections, and that's particularly for EC2 here. So you can see here we can inject and straddle API. So that's a new one that's just been developed, and here I'll show you quickly what it does. It's simply taking an API from a particular service. So we have two operations here that actually going to be throttled, right? And 98% of it is going to be throttled. This is like this just to show you that we can apply a percentage. We can say 50% of my call. We can say whatever you want.
Can you just briefly say what is the control plane in AWS?
A control plane is basically what
put you on the spot.
Yeah, I mean, I don't want to reveal too much, but what all the services that you use on AWS basically have some control mechanism to scale, to verify the call, to make sure that it's routed to the right service, all these kind of things, right? So this call is not happening on an EC2 instance. It's happening on the fabric under the hood, right? So that actually controls and route traffic to EC2 instances, right? So this one will throttles all the API for those two operations, which are describe instances and describe volume, right? So there's another one as well that we can do. There's internal errors, right? So this is another one that we can do.
Yeah. 5 minutes.
So let's do that. So let's go into my console. So let's see if I get it work in 5 minutes, right? So
yeah.
We can create an experiment and see what I get. So what's the name of it? It's internal error.
So this is brand new stuff, Adrian.
That's brand new. As I say, you you don't even have access at it if you are in the beta yet. So this is demo that is out of the box, right? So I've loaded my experiments now, and I will start the experiment. So this is targeting all my EC2 calls with described instances, right? So now let's log into EC2 instance. Well, of course, I'm sure I restarted that instance, and then it's SSH. Yep, this one changed. So let's take one.
It was part of the previous experiment.
Yep. So we're here. So if I go here and I do an EC2 describe, something like this. So AWS EC2 describe instances. And
there's one has too many in describe.
Hold on. Here. So let's verify first that actually the experiment is running. And it is running. Yes, that's good. So this call should not be, should be subtle. So with an internal error. So yeah, so it's worth to say that the AWS CLI has a retry, 4 retries by default, and you can see it now returns an internal server error, right? So if I stop that experiment now, if I do an A/B phase and stop, right? So I go verify quickly that it is. It's stopping. So now, if I do the same call, my describe instances is working. Right? All right. So this is brand new out of the box.
That is very cool. So this experiment actually happens on the control plane. It's not about blocking traffic from the instance. We're not using an agent on the instance that's doing anything.
Correct. So traditionally, you would do that maybe with an IP table on EC2 instances. So then you'll have to have an agent and load that agent on all the EC2 instances. Now it's not done like that. So now that's really targeting all of this. And as you can imagine, if you look at that experiment, you can imagine we're actually gonna support a bunch of services as well. So you can imagine S3, DynamoDB, and all these kind of things that are gonna come on the control level plane. So we'll be able to actually simulate the real errors from returned by those services. And this is something that is very unique that we can't do any other way, right? So this is one of the reasons we built Fizz as well.
Yeah. So then you're able to uncover those unknown unknowns. What happens when you're not able to use S3, for instance? So you're able to ask those questions and then do experiments to answer them. All right, so it's time to wrap up, Adrian.
There was a good question from Rob, right? So we'll be able to target resources on EC2, ECS, and Lambda, and the answer is yes. Eventually, yes.
Yeah, we'll get there. All right, cool. So great session, Adrian. Thanks for being here and to showing us more about AWS Fault Injection Simulator, talking about chaos engineering, the whys, and a bit of background around it as well. Thanks everyone for joining us today as well. So this was a session in the Nordics Office Hours series with me, Gunnar Grosch, and I had Adrian Hornsby with me today. And I bet Adrian would be happy to be here again if possible.
Yeah, so it's always a pleasure to talk to you. You're my brother, so
yeah. Thanks. This is great. So thanks everyone once again. We have several cool sessions coming up in the next couple of weeks, every Monday 1 p.m. So join us then. Thank you very much.
Thank you very much. Bye-bye.